Hi there, in this video I will be discussing mutations. In order to understand the material, we must first start at the basics. Remember that a mutation causes changes in the function of protein. More specifically, it can cause a loss of function or a gain of function. The loss of function shows complete or partial absence of protein function. This would be, for example, if a recipe in a cookbook calls for 2 eggs but you forget to put them in the mix, then it will not turn out the same. Then, a gain of function means that a cell produces protein that is not normally present. For example, again, if the recipe calls for 2 eggs but you mix in 4 instead, it will turn out differently. Now in this video, we will focus specifically on what is known as point mutations. These cause the substitution of one base for another. Here we have 2 types. Transition, which changes a purine to a purine and a pyrimidine to a pyrimidine, and a transversion, which changes a purine to a pyrimidine and a pyrimidine to a purine. Point mutations also have different effects which can be classified as missense or non-synonymous, nonsense, silent or synonymous, and read-through. To demonstrate these mutations, we will look at this example coding strand. First, we must start by transcribing it, which will give us a template strand. Afterwards, we must make this strand and translate it into the mRNA. This gives us a coding for the amino acid sequence, which in this case is methionine, tryptophan, asparagine, alanine, cysteine, and the stop codon UGA. First, we will be looking at the missense effect, which causes a change in the amino acid that is coded, for which example occurs in sickle cell anemia. Here you can see the original and mutant strands. Specifically here, A8C mutates into TAC, which then becomes ATG and UAC, which codes for the amino acid tyrosine. As you can see, there is a change in the amino acid since the original strand coded for asparagine instead. This would then be classified as a transversion because it changes from a purine to a pyrimidine. Then we see the nonsense effect, which changes the codon into a stop codon, therefore stopping translation earlier on. In this example, you can see that the original TGC mutates into TGA, which then becomes ACT and UGA, changing the codon into a stop codon. This would be classified as a transversion since it changes from a pyrimidine to a purine. Next, we have the silent effect. Here, the protein codes for the same amino acid even after the mutation has occurred. In this example, we see how GCT changes into GCC, giving us CGG and GCC, which then codes for alanine. As you can see, this is still the same amino acid as the original codon. This indicates a transition since a pyrimidine changes into a pyrimidine. Finally, we have the read-through effect, which causes the stop codon to change into a codon that changes for another amino acid, therefore continuing the translation and making a longer protein. As you can see here, TGA changes into TGG, which then gives us ACC and UGG, which codes for tryptophan rather than the stop codon we had originally. This effect also creates 2 new codons as translating continues, giving us proline and glycine. This indicates a transversion since it changes from a pyrimidine to a purine. In the end, we have our new mutant strand, which codes for a new amino acid sequence that contains the 3 new amino acids we created. Thank you for watching!